absolutely delighted to welcome you to our second FoLO family dinner. And it's an absolute honor to be on this side of welcoming Andy Fraknoi. He is usually the one standing up here giving the introduction for another scientist. So many of you know him from his work ongoing at Foothill College doing that lecture, which we are now co-sponsors with the FoLO board, UCO and Lick. But those of you who have seen him over these times or watched the YouTube videos where he's introducing other folks might not realize that he himself is a retired professor of astronomy who is recognized for his lifetime of work using everyday language to make astronomy more accessible and popular for both students and the general public. He's written books, he's served on the board of SETI, and he's currently serving as our chair of the Friends of Lick Observatory board. I am absolutely delighted to introduce you, if you haven't met him, or reintroduce you to Andy Fraknoi. Andy, welcome, and thank you so much for joining us tonight and speaking to the FoLO membership in particular.
Well, thank you very much, Natasha, and it's a real honor to have been elected the chair of the Friends of Lick Observatory board. I was part of the Lick Observatory Council, which we founded to essentially save Lick Observatory a few years ago from the budget acts, and with Alex Filipenko's help and a lot of other people, including some who are here, I see at the gathering, we were able to overcome the threat, and now we've even survived the terrible fire. And I think Natasha will give us a little bit of a progress report on that. But the good news is that the instruments are all okay. All the scientific buildings were saved through the heroic action of the fire companies that were up on the mountain surrounding the observatory. And so that the work of Lick, which has been going on for 130 years, can continue. Let me say a few words about how this is going to work tonight, and then we'll get right into the moon. I want you to know that the Lick Observatory staff arranged for a blue moon on Halloween yesterday. I hope you were all able to appreciate the second full moon in a month, which is what we're now calling the blue moon in astronomy. I want to encourage people to ask questions, and we have the chat room, which is available if you move your cursor down to the bottom of your screen. You can get into the chat room. This is designed as a family program, so I don't know how many of you have invited or encouraged kids or young adults to be part of this. If you have, can I ask you to list their name, their first name, and their age in the chat room? So we'd love to see if there are any kids involved. If you have a kid who's listening in because of you or with you, put the name and the age in the chat room. If not, people of all ages are welcome. There's no requirement. All right. And what I want to do today is to talk a little bit about the moon as a scientifically interesting object, as well as an object of interest to all of us. So I'm going to go straight to my slides. Many of you know that the last year was the 50th anniversary of the first human step on the moon. So we are now 50 plus years after the first step. And one of the things that really bothered me about our celebrations for that 50th anniversary is that NASA and the media did a whole bunch of stuff on the brave astronauts and what they had for lunch and how we celebrated when they got back. But very little was actually said about the astronomy of the moon. And as an astronomer and astronomy educator, I found that kind of annoying. So I offered to put together a talk about the moon itself, not just our brave exploration of it, but the moon itself. What do we know about the moon today? And so let me start right here with our next slide. Here is the moon as seen from the most important place in the universe, the Lick Observatory. This is actually an image taken by an amateur astronomer, Rick Baldridge, who's part of the Peninsula Astronomical Society. And it shows you that with a magnifying lens, the moon can be a dramatic object in our sky. Here's one of my favorite pictures of the moon. This is actually color exaggerated, so your eye wouldn't see the moon this colorful. And the colors bring out subtle differences in the composition of the different features on the moon. But what I want you to notice, even in this very first image we're dealing with, is that things on the moon are round. And if things don't look round, you're not looking hard enough. So if you take a look at all these craters, large and small, light and dark, all of them are a superposition, a putting together of round features. The biggest events for the moon are things hitting the moon. And when a chunk of rock from space hits the moon, it explodes. And it generally makes a round crater about 10 to 20 times its own size. So what you're observing here on the moon are billions of years of impacts, of things hitting the moon. In the early days, much bigger things hit the moon, and those are the dark, large craters we see. And then, for example, here near the top, you can see silhouetted some smaller craters. We'll see much more of this later on. And all of those craters are round. Even here, where it looks like the craters have humps, these are really the superposition of many round craters, one on top of the other. So craters are the big thing on the moon. Now, we've explored the moon from the Earth. We've explored it from orbit. We've explored it from down on the ground. In 1969, the first human being came down the steps of the lander. Of course, this can't be the first human being to come down the lander, because then who took the picture? So this is actually the second human being to come down the steps and step on the moon. And so I want to talk a little bit about the moon itself and then its origin as well. Here is a kind of quick snapshot of the 4 planets that make up the inner solar system. And out of those 4 planets, it turns out only the Earth has a moon. Now, wait, if you're an astronomy fan, you know that's not right. Mars has 2 moons. But ladies and gentlemen, those 2 moons are pathetic. They're just captured asteroids. They look like diseased potatoes. They're really small. They're not the kind of moons you bring home to mom with pride. So the only planet that has a significant, substantial, appreciable moon is the moon that we have. And here it is to scale in size. Our moon is about 1/4 the diameter of the Earth. And it's as big a moon as you have in the inner solar system. The surface area of the moon, because there are no oceans there, so it's all surface, is just a little bit smaller than the size of Asia, the continent of Asia on Earth. And the gravity on the moon, because it's so much smaller, is about 1/6 the gravity on Earth. So if you were to land on the moon and you weighed 180 pounds on Earth, you'd weigh only 30 pounds on the moon, which is really quite nice if you're into Jenny Craig or other kinds of weight reduction. Unfortunately, only your weight decreases, not your mass, but well, we can talk about that later. By the way, the astronauts took a little while to get adjusted to that lower gravity. They tripped and fell a couple of times, and once they got the hang of it, though, they loved high jumping on the moon because the gravity allowed them to jump much higher. Also on the moon, there's no air. Temperatures on the surface can vary from 250 degrees Fahrenheit in the sunshine to minus 240 degrees Fahrenheit in the cold middle of the night. So make sure you bring your spacesuit. There is day and night on the moon. Each lasts about 14 Earth days. So if you're on the moon, you have 14 days of sharp sunlight and then 14 days of utter cold darkness. Now, this is the size scale model, but let's take a look at the distance scale model. You can see on this image that the moon is 30 Earth diameters away. And that's a bit further than most people put it. When you ask students, how far away do you think the moon is? Generally, people estimate closer than that. So it's 240,000 miles away. If you drove at 60 miles an hour, never taking a break, it would take you 5 months to get to the moon. So images like the one I showed you with the two of them close together are kind of misleading. Let me show you my favorite picture of the Earth and the moon. Here you can see that the moon really is going around the Earth. This is a picture taken by the Deep Impact spacecraft, and it was taken from 31 million miles away, going away from the Earth-Moon system. And here you see that it really is a system in motion. Another thing we know about the moon is that it has something called synchronous rotation, which is a fancy way of saying that the moon goes around the Earth at the same rate that it goes around itself. Now we have to think about that. So every time the moon goes a little bit around the Earth, it also turns a little bit on its axis. And it takes the same time to complete both those motions. So in this diagram, you can see a person, a blue person, pointing toward the Earth from the moon. And then you can see that as the moon goes around us and goes around itself, the blue person on one side of the moon keeps pointing toward the Earth. Or you could put it this way, from the Earth, we always see the blue person if we could see something that small. So that means that we always see the same face, the same side of the moon pointing toward us. There is a near side of the moon and a far side of the moon. And from Earth, we only see that near side. That far side eluded us until we had spacecraft to go on the back of the moon and show it to us. I'll show you a picture of that in a little while. So that's interesting. When you look at the moon, it's always the same side that we see, the so-called near side. By the way, for Pink Floyd fans, there's no dark side of the moon. All sides of the moon get light and dark, but there is a near side of the moon. And here's a black and white image, the same one I showed you. This is actually, again, a picture which shows you the many dark craters on the moon. We call these from ancient tradition Maria, which means seas in Latin. In the early days, when people didn't understand the moon, they thought these might be dark bodies of still water, but we now know that these are huge craters, ancient craters, flooded by dark lava from underneath, giving them that dark appearance. By the way, I should tell you that this kind of syncing up that I talked about, where the rotation and revolution of the moon got to be the same time that the moon rotates and revolves in the same period, that's something gravity likes to do. Gravity is like your uncle. It's pretty cheap. And so it likes to get into sort of minimum energy situations, situations where the least energy is required. And that happens, for example, on the moon, the big moon of Pluto's too, where the moon is synced to the motion of the planet. But something else interesting happens because of this syncing up, this exchange of energy between the Earth and the moon. The moon, being locked in Earth's gravity embrace, can pull tides, can pull the water on the surface of the Earth, and it can cause the waters of the Earth to swell up and down in every location and to rub against the Earth. And this tidal rubbing actually has a rather dramatic effect. The tidal rubbing slows down the turning of the Earth, and that gives some extra motion energy to the moon. The upshot of this is that the Earth is turning slower as the many millions of years go on, and the moon actually moves away from the Earth very slowly. So what? Say that again. The Earth's day is slowing down. And as a result of the fact that the energy has to be balanced in the system, the moon is actually gaining energy and moving away from us. Now, you might say, wait a minute, I've watched the moon all my life and I haven't seen it move away. But that's only because it's a very, very slow motion. But you have every right to ask my favorite question in science, which is, why should I believe a word of this? And later on, I'm going to prove to you that this is, in fact, what happens, that the moon is moving away and how we know that. So what we're looking at here is a fully illuminated moon, but I think everybody knows that that's not the way the moon always looks. The moon is the only object in the sky where we can easily and dramatically see it change over the course of a month. Here are the monthly phases, if you will, the changes in the illumination of the moon as seen from Earth. Because the moon is going around the Earth and moonshine is just reflected sunshine, we actually see different amounts of sunshine on the face of the moon as the moon goes around us in the course of a month. And so this is something which most people are aware of. There are many legends about what the full moon versus the half moon or the crescent moon will do. You can read all about that in Harry Potter novels and books of mythology. But for us, this is just a beautiful thing that the moon does. And we wondered, what would it look like from the moon? And here you can see an actual picture from the moon where the Earth too has phases, where the Earth too changes its illumination as seen from the moon. We now know that the Earth will have phases that are the opposite of the phases we see of the moon having. So if you stand on the moon and I ask you what phase is Earth in, and then I'm on the Earth and you ask me what phase is the moon in, they will be the opposite phases. And here's a diagram showing you the phases of the moon in a given month and the corresponding phases of the Earth as seen from the moon. And by the way, because the moon keeps one face to the Earth, this is really going to influence future real estate values on the moon. That means that there's one side of the moon, the far side, that never gets to see the Earth, and one side of the moon, the near side, that gets to see the Earth go through these beautiful phases. So naturally, it's going to cost a lot more for a vacation home on the near side of the moon than the far side of the moon, because you get to have Earth phases thrown in with your house or apartment. All right. So here is another picture of the moon. This is actually a picture taken at Lick Observatory, and it's a picture that's cheating. If you look carefully at this picture, the shadows on the left don't agree with the shadows on the right. Can everybody see that? If you look at the shadows inside the craters, as your eye moves left from the middle, and then your eye moves right from the middle, the shadows are not the same. This is two half-moon pictures that were pasted together in the early equivalent of Photoshop to give you a more beautiful full picture of the moon with good shadows, to give you a better sense of all the craters, because the craters become more visible when you can see the shadows. So this is a lovely picture of the moon, and we've labeled in this picture some of the names that we've given, the dark craters and some of the more famous lit up craters on the moon. We astronomers have been kind of selfish, and we've named some of the biggest craters on the moon after famous astronomers. So you can see the Copernicus crater, the Kepler crater, and so on. And then here you see these big dark craters, which come from the early history of the moon that were flooded by lava when the moon was still partly molten. And they too have names. They were given names of emotions. So here, for example, is the Sea of Tranquility, Mare Tranquillitatis, the Sea of Tranquility. Here's the Sea of Fecundity, etc. And it was in the Tranquility crater that we first landed on the moon. Now, we think that these dark craters are so old that they were there very much at the time that the moon had formed and was starting to cool down. These giant dark craters make up about 17% of the face of the moon. And we think that when the dinosaurs looked up at the moon, if they ever looked up, they too would have seen these same dark features because these have been there for billions of years. They attest to the early history of the moon when large chunks were hitting the moon and making big explosive craters. Then some of the smaller craters are more recent, and they tell us more about how collisions have affected the moon recently. So here's a little diagram showing you what we think happened early on when those giant maria, those giant dark craters formed. We think large chunks that were still flying around the early solar system because the formation of the planets and moons was not yet finished about 4.4 billion years ago. Those large chunks hit the moon, made a huge crater as they exploded, and then material from underneath, the molten material from underneath, came up and filled that large crater that the impact left behind with dark lava. We call it magma when it's inside, but lava when we see it outside. And that's why those big round features are dark. They're filled with dark lava that erupted early on. The highlands, the other kinds of features on the moon, the brighter features, they make up about 83% of the moon. And then you look at this picture and you say, wait, no, those percentages don't work out for me. I see much more than 17% covered with dark features here on what you're showing me. And that's because, for reasons we're still not entirely sure of, the backside of the moon, the far side of the moon, is deficient in these large dark maria, in these impact craters. And there are many more highlands on the backside. Again, the backside only became visible to us when we had spacecraft to go around the moon and show us what the backside of the moon looked like. This is from Apollo 16. It's the backside of the moon. All right, and let me continue to encourage people, if you have questions, to put them in the chat box, because I'm soon going to take a little break and we're going to have an opportunity for questions. But let me do a few more things before we do that. Let me remind you about human moon exploration. Here are kind of the lunar firsts in the history of our exploring the moon. The first human object to reach the moon crashed into the moon in September 1959, but although crashing wasn't, exactly what we wanted, it was a great first achievement to get something to the moon not long after the beginning of the space program. This was a Russian mission. Then Luna 3 in October of that year actually flew by the moon and got the first not great pictures of the far side of the moon. And then the first thing to actually land on the moon took till 1966 when Luna 9 did the first soft landing on the moon. All of those were Russian firsts, but then the United States caught up in July 1969, and Apollo 11 represented the first human landing on the moon. And I think many of the older people in the audience here remember where they were on that July day in 1969, when we all felt a lot of happiness as residents of the United States, as members of the human race, that we had done that. We miss that feeling of togetherness now with the politics that seem only to divide us and not bring us together. But no political remarks here. This is an astronomy talk. And then in January of last year was our first soft landing on the far side of the moon. And I'll show you pictures from that soft landing and the rover that landed in January of last year. All right, so here is one of the first two people on the moon. This is Buzz Aldrin with the US flag. This is the picture that has caused a lot of trouble among conspiracy theory nuts because it looks like the flag is waving, and that led to this theory that we didn't really land on the moon. The only way the flag could be waving, since there's no air on the moon, there can't be any wind blowing this flag. The only way this flag could be waving is if this was a fake picture taken on a sound set, on a kind of movie set on Earth, which NASA had to provide because they never got to the moon. Nothing could be further from the truth. We actually have pictures now from orbit of where we landed on the moon and the tracks that the moon astronauts made. The reason the flag seems to be waving is that it was made of essentially aluminum foil, colored aluminum foil. The aluminum foil is held by a vertical stick and by a horizontal stick on top, but they had to pound it into the soil so it would stand up. It would have been embarrassing if the American flag had been put in the soil and then fell over in the moon dust. So they really pounded it, and that crinkled the aluminum foil. And there's even a conversation with Mission Control where the astronauts ask if they should straighten out the aluminum foil, and Mission Control says, no, it's very romantic like these. It looks like it's waving. Leave it like that. Much now to the regret, I think, of NASA because of all the conspiracy theories that this crinkled foil has caused. But not only did the astronauts get to the moon, they were able to return to the orbiting spacecraft and then come back to Earth. And that was followed by 5 other Apollo landings, some of which actually took a little car to the moon. This was one of the first electric cars, battery-powered electric cars. It was quite something. Its top speed was 8 miles per hour. The furthest they got was 12 miles away from the landing site. But still, to see these beautiful little cars driving on the moon was quite thrilling back in the late 1960s. Also left on the moon were some instruments, a whole package of instruments, some to measure the earthquakes. We should call them moonquakes if they're on the moon. And also some reflectors were left on the moon, some reflecting panels which were designed to point at the Earth and reflect light. And this had been planned with an experiment to send a laser light, a laser beam from the Earth to the moon, reflected off these reflectors that were left by the astronauts, measure how long it took to come back, and from that, to measure the distance to the Earth, between the Earth and the moon, better than it had ever been measured before. And here's where the Lick Observatory comes into play. A number of observatories participated in this experiment to send a laser beam to the moon. And in fact, the Lick laser was the first to do the experiment. So it was the Lick laser beam. This is not a picture of it in 1969. I'm cheating here by showing you a beautiful current picture of the Lick Observatory with a laser beam that's designed to help us get more precise images. But it's the same idea. The 120-inch telescope that we're so proud of at Lick Observatory was the first telescope on Earth to measure the distance to the moon. And nowadays, we're able to use this reflecting technique to measure the distance to within inches. Literally, we know the distance between the Earth and the moon to within inches. And that is what's allowed us to, this idea, this radical idea that I talked to you about a few minutes ago, that the moon is moving away from the Earth. The moon is moving away at 1.5 inches per year. That's roughly the rate at which your fingernails grow. But we've been able to confirm this quite well. In a century, it moves away about 4 yards out of 240,000 miles. That's why you're not aware of this motion, because it's very, very slow, but it's actually happening. The rate of change has been measured. Also, geological records have enabled us to know that the Earth was spinning more quickly in the past, and that its spin has slowed down, just the way I hinted. And so we now know not just about the moon itself, but also its relationship with the Earth, and that the two, although they like each other a lot, are, like many relationships, getting slightly distanced these days. All right, let me stop there. I want to mention that a lot of people first fall in love with the moon when they fall in love with the sky. This is a way that I think many people who are now either astronomers or astronomy fans have first gained an interest. And here's a picture of a young fan who enjoys looking up at the sky. And I'll stop there. I'll stop sharing for a minute. And let's see if there are any questions that I can answer.
We have a couple of questions here started. Mark asks, were seismic instruments involved in studying the mantle of the moon and the rebound theory for dark craters?
Yes, so this is a technical question having to do with how we measure the insides of worlds. So one of the things that if you've studied anything about the Earth is that we know the Earth, for example, is made up of layers, but we've never drilled down to most of those deep layers inside the Earth. So how the heck can we scientists make a statement like that? And the answer is that waves pass through the Earth, and the way they are reflected and the way they're passed through the Earth tells us something about the structure inside the Earth. These waves, when they're made with earthquakes, are called seismic waves. And we've actually established some of the deeper structure of the Earth using seismic waves. And the question very correctly suggests that that's a way we've also known about the inner structure of the moon. We don't have moonquakes produced by the same processes we have on Earth, on the moon, but every time something hits the moon, it causes the equivalent of a quake. It shakes the moon, and the waves from that and the instruments we left behind on the moon allow us to make those kinds of measurements. All right, next question.
Can you talk to us a little bit about why SETI wants to build an observatory on the moon and when that might actually happen?
Okay, so for those of you who are not in the know, SETI means the Search for Extraterrestrial Intelligence. And as Natasha kindly mentioned in the introduction, I'm actually on the board at the SETI Institute, which is one of the main scientific groups carrying out a search for life elsewhere. So how, if we want to know whether there are the equivalent of Friends of the Lick Observatory on other planets, how the heck can we do that from Earth? And we have a number of ways now that we've thought of, but perhaps the most interesting and popular way is if they communicate just like we do with radio waves. Many of you know that radio and television waves travel at the speed of light. We can code into them radio shows or TV shows and decode them at the other end. And so we wonder if alien civilizations might not do that too. Code into their radio messages, let's say, to each other and to their worlds, some kind of message that we can overhear. So since 1960, when Frank Drake first did the first experiment that listened in on possible radio messages from alien civilizations, we've been pointing radio telescopes at outer space, at other stars, to see if we can overhear any coded messages that show signs of intelligence in outer space. And the problem is there are many kinds of radio waves that don't make it through the Earth's atmosphere because our own atmosphere is a good absorber of different kinds of waves. So one place that we really want to do this experiment is in outer space. But to catch faint radio signals from alien civilizations far away, we need a big antenna. We need a big dish, as they say in sports bars, to pick up their messages. And such a big dish is hard to build in space. So the thought has been given for some years, why don't we build such a giant dish or an array of radio dishes on the backside of the moon? On the backside of the moon, there's no interference from Earth. There's no air. It's a perfect place to search for such alien messages. Now, the expense of carrying that big dish to the backside of the moon is still pretty significant, but the hope is someday we might have interference-free SETI antennas on the backside of the moon. Given our current budget, don't hold your breath. This isn't happening anytime soon. All right, let's do another question or two, and then I'll go on.
Sure. You know, it's been 50 years since we figured out how to safely land on the moon. Why don't we spend more time there in general, since it's one of the only places that we can reach as human beings in a short time?
So many space fans have this question. How come since the Apollo mission, more than 50 years, we haven't sent people back anywhere except orbit around the Earth? And the answer is money. We have the capability, but it's very, 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 very expensive. And in terms of exploring the universe, many astronomers, me included, feel that if you're going to be doing exploration, getting to know what's out there, it's so much easier to send robots to the moon or robots to outer space than it is to send people. But now there is this Artemis program. The current administration has put forward the idea that we will have not just people, but a woman going to the moon. I like that. That if we send people back to the moon, the next person to step on the moon should be a woman. And so that program is underway. It's called the Artemis program, but it's behind schedule and behind budget. And nobody knows what's going to happen if there's a change of administration. So everyone stay tuned. Okay, let me stop there, Natasha, if I may, and go back to the slides, and then we'll have lots more time for questions at the end. So I'm going to share my screen again, get back to the young lady who wants to be an astrophysicist, and let's talk a little bit more about what we know about the moon. So I ended up by saying that there's now good evidence that the moon is moving away from us. And someday this is going to have a dramatic effect on one of my favorite things in all of astronomy, which is an eclipse of the sun. Now, I think many of the friends of the Lick Observatory know this story, but let me just mention it for the young people. It is a wonderful coincidence that as seen from Earth today, the size of the moon in the sky and the size of the sun in the sky are exactly the same. And so it can happen when things are aligned just the right way that the moon exactly covers the sun. And we get this really beautiful thing that we had in 2017, a total eclipse of the sun. The moon's mountains allow some light to come through here. So the valleys of the mountains allow more light. And you can see the outer atmosphere and some explosive phenomena in the outer edge of the sun on this beautiful picture. But essentially, the moon can completely cover the sun and cause what's called a total eclipse. And if the moon was closer to us in the past, it would have more than covered the sun, and beautiful pictures with the edge of the sun visible wouldn't have been possible. And if in the future the moon is slowly moving away from us, someday it will no longer be possible for the moon to cover the sun completely, and total eclipses will no longer be visible. So I want to congratulate every one of you on having the good taste to be born now, at a time when the moon exactly covers the sun. That's probably the most fun time to be aware of the sun and the moon. Now, why are such eclipses so rare? We know it's because the circle that the Earth makes around the sun, and the sun seems to make around the Earth, and the circle that the moon makes around the Earth, those two circles are actually tilted relative to each other. So most of the time, when the moon and the sun might be in the same general vicinity, they're not quite aligned because the two orbits are not aligned. And only where these two circles cross, the moon orbit circle and the Earth orbit cross twice a year, only in those 6-month intervals is it possible to have eclipses. And then you have to be on just the right part of the Earth, which we rarely are, to actually see the exact alignment. And so that's why eclipses are quite rare. But while we're on the subject, if you don't already have this on your social calendar, let me mention that even though the United States had a total eclipse visible from a path that went through our country in 2017, in an unexpectedly close time, only 7 years later, we're going to have another total solar eclipse. So if you don't already have plans, we hope the COVID will be a thing of the past by then and everyone will be able to travel. And here's the path where in April 8th, 2024, we will have a total eclipse visible. So it doesn't come through California, but it'll be especially good in northern Mexico and southern Texas. So if you have any relatives in that part of the country, get really friendly with them soon so they invite you in 2024 to share the total eclipse with them. So that's a little thing I wanted to mention about the consequences of our moving away from each other, the moon and the sun, the Earth moving away from each other. Now let me get back to the question of how come the Earth has a big moon and the other inner planets don't? Where the heck did the moon actually come from? And we thought that there were only two solutions to this problem. Either the moon came from the Earth, it somehow got loose from the Earth itself, in which case what the moon is made of should be very similar to what the outer layers of the Earth were made of, or the moon came from elsewhere and got captured by the Earth, in which case the moon's rocks may be made of quite different things than the Earth's rocks because it came from somewhere far away. And we thought once we got to the moon, and the astronauts actually brought back the hundreds of pounds of rock that they eventually managed to bring back, we would examine those moon rocks and we would know whether the moon came from out of the Earth or from far away. And the answer, as often happens in science, is neither one. The moon rocks were not so similar to the Earth that they could have been from the Earth originally, not so different, though, that they could have come from far away. So both of those theories were not confirmed by the actual experiment of looking at the moon rocks. And we had to come up with a better theory of the moon. Two pairs of US astronomers, one from Arizona, one on the East Coast, came up with our better theory at the same time after the moon landings showed us that our first thoughts were not correct. And here's the idea. It's called the giant impact hypothesis. And what it says is that back in the early days, before the Earth had solidified, when it was still a little bit molten, and when big mini planets were still flying around the early solar system, before things had settled down to their present state, a giant mini planet, maybe even as big as Mars, hit the Earth. Either it hit the Earth straight on, as this painting shows, or it had a glancing blow. But whatever happened, a lot of material from both the outside of the early Earth and the outside of this giant impactor then went into orbit. There was a lot of garbage, a lot of debris, debris being French for garbage and sounding much better. There was a lot of debris that went into orbit around the Earth. The debris gathered together and it made the moon. And that's why the moon is similar in some ways to the Earth, because it includes some of the outer material of the Earth from this collision, but also somewhat different because it includes some of the outer material of this mini planet that hit the Earth. We're not sure if this theory is more correct, but it's certainly all the evidence we have so far of what the moon rocks are like fits in with this giant impact hypothesis. Eventually, the moon cooled down and made the moon we have today. Uh, and then all traces of these ancient collisions were wiped out, except for the ones that made the dark giant craters on the moon, which were made by slightly smaller ones than this mini planet, but still impressive objects. And then after the moon cooled, much smaller chunks kept hitting the moon, and those smaller impacts continue to today. They pulverize the surface, and they make what we call moon dust. The reason that the moon had this dusty surface in which the footprints of the astronauts could be seen so clearly is that these impacts have continued for billions of years. And they, over this long period, pulverize the moon and make it into a fine powder. We worried a little bit before we actually got to the moon about whether that fine powder would be so thick that the astronauts would sink into it like quicksand, and that would be very embarrassing for our first landing. But landing robots on the moon showed us that the moon dust was not so thick and that it was safe to land people on the moon. And after that, we've continued exploring the moon with robots, not with people, from orbit, and actually landing some robots. Many countries have sent robots to the moon, and I mentioned that the Chinese recently landed a lander and a little rover. The little rover is called the Jade Rabbit on the moon. And so here you see a picture from the back side of the moon where no one has landed softly before. And here you see a picture of the landing craft as taken by the rover, and a picture of the rover as taken by the landing craft. You see the landing craft making tracks in the moon soil right over here. This is Chang'e 4 and U2, the Jade Rabbit, now giving us lots of good information on the backside of the moon. And I should say that in order for that information to get back to Earth, the Chinese also had to put a communication satellite into orbit around the moon so that signals from the backside of the moon, which don't make it to Earth, could get to that orbiting satellite and then be transmitted to Earth when it's on the Earth side of the moon and not on the backside. So this has been a very interesting mission, and stay tuned. We're going to learn more about the back of the moon from this landing. All right, and another thing that we've learned from the moon, and you may have heard a little bit about this in the news, is that even though the moon has no air and no air pressure, and therefore there can't be any liquid water on the moon, we have been able to identify quite a bit of water on the moon. Originally, these ice deposits, this frozen water deposits, were found at the moon's poles. And we now understand why. By the way, this is not the full moon. The circle here shows only a small part of the south polar region and a small part of the north polar region of the moon. And we now know that where we can find water ice is inside deep craters. There are deep craters on the polar areas of the moon, just like there are all over the moon. And those deep craters, if some chunk of ice from space were to hit, we call such chunks of ice comets. If a comet were to hit the polar region of the moon, even though it might explode, the water would eventually freeze in the dark, cold craters. If the crater is deep enough at the poles, sunlight never reaches into those deep craters. And so the frozen ice could stay there for millions of years undisturbed. And so we think that the signals that we've been getting from the moon that indicate frozen water come from these deep, dark craters in the polar regions of the moon. But we weren't sure. So in 2009, the Lunar Reconnaissance Orbiter spacecraft turned out to be heavier than they expected, so they had to put a bigger rocket to launch it, and that gave them a chance to put a stowaway, an extra mission with the Lunar Reconnaissance Orbiter called LCROSS, the Lunar Crater Observation and Sensing Satellite. And so before the Lunar Reconnaissance Orbiter went into orbit around the moon, it launched this set of a small spacecraft to fly at the south pole of the moon. And there was a rocket stage, which you see in white here, which was going to hit one of those deep craters and see what plumes of material came out. And then this bluish sensing satellite was going to smell what the plume of material from this deep crater was like to see if it was made of water. And this worked. And we actually managed to get good evidence from the plume from the south pole of the moon that there was considerable amounts of frozen water in the deep, dark craters of the moon. You may have heard that, oh, and here's the actual image showing you kind of what it was like. This is a diagram showing you the sensing spacecraft after the little impact stage hit the craters, a plume of material came out, and we sensed that there was water in it. And then you may have heard that we have a flying spacecraft, a flying airplane, which goes up into the stratosphere, which is called Sophia. It flies out of different NASA bases. It used to fly out of NASA Ames, actually. And Sophia has a heat ray sensing telescope, an infrared telescope on board, and using this for the first time to point it at the moon, which was a whole new thing for them because they usually look into deep space. There was a recently published experiment which saw some evidence for water on the moon, not inside these craters, but in shadowed regions in the other parts of the moon. So the parts of the moon facing us actually showed a little bit of evidence for water. It's still a little bit controversial and not enough water that anyone can think of swimming pools on the moon, but nevertheless, there was a tiny bit of extra evidence for water on the moon recently. All right, well, let me finish up by saying that what people dream about, not just astronomers, but science fiction fans, are what we talked about a little while ago, bases on the moon, maybe a giant dish for SETI, maybe some other scientific experiments, maybe digging deep into the moon, into caves where we can have colonies. People worry about the fact that we're not especially kind to our own planet, and that we literally have all our eggs in one basket, in the sense that the Earth is the only place that life on Earth has its genetic material. And some people worry about whether we should not have a genetic bank, a gene bank for Earth life on the moon. So if something terrible happens to our own planet, our genetic material is preserved on the moon. But even without that, people dream of someday having bases on the moon and maybe even having tourism on the moon. And certainly one of the objects of tourism in the future will be those first footsteps that human beings took on the moon more than 50 years ago. Those footsteps, because there's no air or water or teenage children on the moon, will be preserved on the moon for millions of years. And someday we'll be visiting them and looking back at the Earth, perhaps, thinking the same kind of big thoughts that we on Earth like to think about space. So for more on UC observatories in Lick, there's a website you can go to. For more on some of the work I do, there's my website. Let me thank everyone for tuning in on this family event for the Lick Observatory. And I will stop sharing and we'll take a look at whether there are more questions from the group. But thank you very much.
Thank you, Andy. And please, anyone, feel free. Since this is a FoLO family dinner, it's intended to be a more exclusive event, and you can feel free to just turn off your mute and ask questions directly yourself. But until any of you do that, I'll continue to ask questions that some of you have sent me. Andy, what is it about the moon that draws the human imagination so much? Is it just that we can see it? Why that versus everything else in nature?
Well, this is above my pay grade. I'm only an astronomer, but I'll venture a few guesses. I think there are a couple of things that are especially romantic about the moon, right? That it's in the nighttime sky. We're used to not being able to see light uh, at night. We're used to it being dark at night. So it's a real relief when there's a full moon and suddenly it lights up the night world. And that's when lovers like to go strolling. That's when it's safe to do nighttime biological exploration, etc. But at the same time, poets and storytellers worried about whether the cold light of the moon was not some sort of trap for us humans as compared to the warm light of the sun. And from that came legends about how the full moon was dangerous, that it turned people into strange creatures like werewolves and vampires. And we were warned not to somehow expose ourselves to the danger of the moon. So I think because it does produce a sizable amount of light and the light changes, it captures the human imagination. But then quite separate from that, now that we know that it's our nearest neighbor in space, and the ancient Greeks already knew that, of course, there's just this human desire to want to go somewhere else. And I know that for many of us who have been quarantining with COVID, we're dying to go somewhere else. So I think the moon captures our imagination for that reason too.
Great. One of the members mentioned you use the word pulverized when you're talking about how many craters hit the moon. Why aren't we being hit by that many craters and having, being pulverized ourselves?
This is a great question. And if you've never been grateful for the air that the Earth has surrounding it, this is perhaps the number 2 reason to be grateful for it. I admit that the number 1 reason to be grateful for air is that we like to breathe it. But the number 2 reason is that chunks of rock from space have the courtesy to burn up high in the Earth's atmosphere. And so the air protects us from most of the smaller impacts that happen to the moon, the pulverizing impacts. It's very nice sometimes at night when chunks of rock from space burn up in the atmosphere, they make what we call shooting stars or meteors. And you probably have seen a flash of light when chunks burn up in the Earth's atmosphere. We now know that in the early days of space monitoring, the military of both the United States and Russia identified a whole bunch of big, what looked like enormous military events in the upper atmosphere that had them worried. And only later did they realize that these are chunks of material exploding from burning up high in the Earth's atmosphere. But to finish the question, it's not true that the Earth doesn't get hit. We have experienced hits from bigger chunks on the Earth throughout our history. We know, for example, that halfway between Phoenix and the Grand Canyon, there's a giant crater called Meteorite Crater, which is an example of an impact that happened tens of thousands of years ago and was so large the chunk actually made it through the atmosphere and dug a huge crater there in Arizona. And we know that 65 million years ago, a chunk actually hit the Earth. We now know where, in the outer edge of the Yucatan Peninsula in Mexico. And that impact was probably a chunk almost 10 miles across, and it killed half the living species on Earth. So it's still very much true that chunks of material can hit the Earth. And we have a big program. This is what you pay astronomers for. We have a big program throughout the US and around the world, beginning now to monitor the position and motion of every large chunk in our cosmic neighborhood to see if any of them are coming our way in the next 1,000, 10,000, or 1,000,000 years. We'd like to know in advance. Unlike all the creatures who died in 65 million years ago, we now have the capability of nudging aside any chunk of material, big chunk of material coming our way. And we'd sure like to have early warning so we can do that.
Jeff has a really fun question. Andy, would you like to go to the moon? And assuming so, where would your first stroll be?
Oh my goodness. Well, it's always very embarrassing when I answer questions like this because I actually have fear of heights. So going out into space is not one of my fantasies. I love reading about it, but I personally don't want to get high in any of that sense of the word. But if I were to go to the moon, I would like to explore caves on the moon. I'm fascinated by caves. And we now know that because the moon did have lava extrusions, lava did come up from inside the moon, and then lava subsided when the moon cooled, there are actual empty lava tubes on the moon. By the way, the same is true on Mars. Some of the volcanoes on Mars have lava tubes that are now just empty caves. And whether I go to Mars or the moon, in my imagination, that's where I'd like to go. I'd like to go cave exploring. And then that's a place where I think we're going to also have human habitation because you just have to cover the entrance of the cave and then pressurize the cave. So people are actually speculating about that. And I think some of you know one of my retirement hobbies is I'm writing science fiction stories with good astronomy in it. And my first published story was actually about exploring such a cave on the side of a volcano on Mars. So if you go to my website, you can read that story. But I love speculating about that.
Well,
other questions?
yeah, why is the you showed a couple pictures of the far side of the moon. Why is it so rough with its seemingly more craters?
Yes, so this is a great question, which we're still investigating. Why is it that one side of the moon turned out different from the other? Now, you might at first say, well, maybe that side was different because it faced away from the Earth. But it's not so clear that at the time that these Maria formed, at the time that the big dark craters on the near side formed, the moon was already locked into this synchronization with the Earth. It's not clear that at that time that was the near side of the Earth. So we don't really know why the two sides turned out differently, what that has to do with, but someday somebody's going to get a PhD maybe figuring that out.
Do we have any more questions from the group? Steve, how would we keep ourselves safe from radiation so that we could live long term on the moon? Is that why living underground might be a good idea, or would we use special materials in the surface building? What would that look like?
Yeah, that is also a very informed question, as we expect from Friends of the Lick Observatory. Indeed, because there's no air on the moon, there's also no protection for what's called cosmic rays. Now, cosmic rays is one of the biggest failures in astronomy naming, because when you use the word ray, you expect it to be like a ray of light, but actually cosmic rays are particles from space. They come from the sun, they come from exploding stars, they're channeled by the magnetic field of the galaxy. But these cosmic rays are subatomic particles moving at high speed, which hit the Earth and hit the moon. On Earth, many of the cosmic rays are stopped by the layers of the Earth's atmosphere, but on the moon, they're not. So that's like being in a radiation environment. When we get radiation treatment from cancer, radioactive rocks send high-speed subatomic particles to our cancer cells, and it's the same subatomic particles that come at us from outer space, and we would be unprotected and therefore in some danger of extra cancer and other problems on the moon. So one of the questions that any moon dwellers will have to deal with is how much time you're allowed on the surface unprotected. You presumably would dwell, as Natasha said, in an underground facility or in a shielded facility, but every time you went outside with only a light spacesuit to protect you and give you pressure, you would be exposed to more of these particles, more of this radiation. You would presumably wear the same kind of meter, the same kind of dosage meter that people wear in nuclear power plants. And if you exceeded your yearly allotment, you wouldn't be allowed to go up on top anymore. You'd have to stay within the shielded colonies of the moon. So if you're making plans for future moon real estate, bear this in mind.
Thank you.